Hey guys, Miss Williams here. So since I couldn't be with you all in class today, I wanted to prepare a little bit of notes for you so that you guys didn't sit around waiting for me until next Monday when I come back. So today, if you will make sure that first off that this page that is in front of you is inside of your math notebook and glued down. So if it's not already in there, go ahead and make sure that that's down. And the second piece is the cool thing about today is that you'll be able to pause and rewind the video if you need to, if you weren't able to get what I put down, quite as quickly enough. So we're going to kind of dive into unit rates and starting to talk about ratios and proportions. It should be a little bit of a review from 6th grade, but we're going to kind of build off of it because we're going to get into these things called complex fractions here in a little bit. So the first thing as you're digging into your notes, so we need to figure out what is a unit rate. So you probably remember from 6th grade, or you may, that a unit rate is a rate, and so if you'll go ahead and write this in with me, is a rate in which the denominator of the comparison is 1, okay? So if you want to just make sure that you have that down. And then the second piece of that is, so if you think about where a unit rate's used in the real world, you could think about grocery shopping. And so you could be thinking about how much does each ounce cost if you're trying to compare, the cost of laundry detergent and the cost per ounce, or if you're trying to compare blueberry prices and the cost per ounce of blueberries or whatever it may be. Another example of where you might see unit rates in the real world is gas. So a lot of times, or not a lot of times, most of the time when you all are going out with your parents in their cars and you drive by a gas station, that is the cost per 1 gallon. So that's another example of a unit rate. So it's what is the cost or the amount of dollars per 1 gallon. And then you could also think about if you are price shopping or shopping for a car, a lot of times they're going to advertise cars based on how many miles per gallon the car might get. So you can go ahead and put in miles per gallon. So obviously a big F-150 truck is probably going to get less miles per gallon than a Honda, Prius or whatever it may be. And then another example of unit rates in the real world would probably be as your parents are, driving and looking at the speed limit signs, they're always written in terms of miles per hour. And so that's another example of a unit rate in the real world. And so it's just always a rate in which the denominator of the comparison is to 1. So to 1 ounce potentially, or to 1 cost per gallon, per 1 gallon, or the amount of miles that you can drive with 1 gallon for your car, or the amount of miles that you can drive in 1 hour. So you get the point that it's always compared to 1. Now, the extension of it moving into the 7th grade curriculum is that now we're going to start using unit rates, but we also have complex fractions. Okay, so you might be thinking complex, that sounds complex. Well, complex means that it's a fraction, so you can start to write this in with me. It's a fraction that contains a fraction in its numerator, denominator, or both. So you're thinking, oh my gosh, I didn't think the fractions could get any more complex, right? So an example of a complex fraction might be that you could drive a fourth of a mile in, break my pencil, in 1/2 of an hour. So if we were going to write a ratio, then that ratio would be written as a fourth of a mile is what we could drive in 1/2 of an hour. So that's an example of a complex fraction. You've got a fraction, but you've got a fraction within a fraction. So now let's look at an example of how these complex fractions could apply to actually solving some problems. So if you're looking at number 3, so you've got a 7th grade student can eat a fourth of an ice cream sundae in 1/20th of an hour. How much time will it take to eat the sundae? All right, well, so first off, we need to try and build a rate or a ratio of what they've given us. So they've given us that you can eat a fourth of an ice cream sundae. So I'm going to write that as you can eat a 1/4 can be eaten in 1/20th of an hour. So all I'm doing is I'm creating a rate, and so I could eat a fourth of it in 1/20th of an hour. And then the next piece says how much time will it take to eat the entire sundae. So now which piece of it do we want to be one whole? Are we wanting it to be, or we're trying to eat the entire sundae? So instead of eating a fourth of a sundae, we want to eat the entire thing. So I want this to be one whole needs to be eaten. So I'm going to turn that into 1. And so now you're probably asking yourself, well, how do I get from 1/4 to 1? And we're trying to figure out how long it's going to take, right? We don't know the question mark piece. And so I'm basically scaling up. So you might be asking yourself, well, how do I get from 1/4 to 1? How many times greater is that? Well, what number can I multiply or divide by in order to get from 1/4 to 1? Well, so you could say 1/4 times 4 would give you 1, right? So if I went off to the side and I were to say, I'm going to go over here, 1/4 times 4, and I'm going to say times 4 over 1, wouldn't that end up giving me 1 times 4 would give me 4. 4 times 1 would give me 4, which would just simplify to a value of 1. So that's why 1/4 times 4 would give me 1. Well, so if I'm scaling it up and I'm multiplying the top by 4, then I'm going to have to multiply the bottom by 4. And so if I were to go off to the side and say, well, now I've got 1/20th, and I want to multiply that by 4, I'm going to put that as 4 over 1. Well, when I'm multiplying with fractions, I want to go straight across. But before I go straight across, I always want to look at my numbers that are diagonal of one another and see if I can simplify the fractions a little bit. Well, so 1 and 1, if I'm looking diagonally, the greatest common factor that they have is 1. So I can't simplify my 1's anymore. But I can look to my 4 and my 20, and they have a greater common factor, or a greatest common factor that's other than 1, because both of those can be divided by 4. So if I divide both of those by 4, I'm going to say 4 divided by 4 would give me 1, and 20 divided by 4 would give me 5. And so now I've got much simpler numbers to work with, and 1 times 1 would give me 1, and 5 times 1 would give me 5. And so now I know that it would take me a fifth of an hour in order to eat an entire sundae at that rate, if I were to continue at that rate. Okay? All right, so let's look at number 4. All right, so it says if a fourth of a gallon of paint covers 1/8 of a bedroom, how many gallons are needed to cover the entire room? Well, so first, looking at what they've given us, we can create a rate, right? We can say 1/4 of a gallon. I'm going to write 1/4 of a gallon is enough to cover 1/8 of a bedroom. So again, I'm just building a complex fraction. So 1/8 of the room. And then the last piece of the problem is saying how many gallons are needed to cover the entire room. All right, well, so now you ask yourself, do I know my amount of gallons or do I know my amount of the room? Well, if they're wanting to cover the entire room, my room is now going to want to be one whole of the room, so one entire room. And so now the piece that I don't know is how many gallons that takes. Now I need to ask myself, what can I multiply or scale up or scale down by in order to get from 1/8 to 1? Well, 1/8 times 8 would give you 1. So off to the side, you could say 1/8 times 8, and if you just want to double check it, 1 times 8 would give me 8, and 8 times 1 would give me 8, which simplifies to a value of 1. So 1/8 times 8 would give me the entire one whole room. So now if I scale the amount of the room up by 8, then I'm going to have to scale the amount of the gallons up by 8. So I'm going to also multiply that by 8. So I'm going to go off to the side and say, okay, well, 1/4 times 8. And so now I'm going to say times 8 over 1. And so I'm going to use that same method earlier. You could go straight across, but before you go straight across, always look diagonally and see if you have any common factors other than 1. Well, your greatest common factor is 1, so it can't be cleaned up any further. However, your 8 and your 4, those have a greatest common factor of 4, right? So if we divide both of those by 4, 8 divided by 4 would give me 2, and 4 divided by 4 would give me 1. And now moving straight across, I multiply 1 times 2 would give me 2, and 1 times 1 gives me 1, and so that gives me a value of 2. So now I know that it would take 2 gallons in order to paint the entire room if we were painting at that amount of rate. that assuming that only 1/4 of a gallon is how much it takes to paint 1/8 of the room. All right, so let's look at the last one that we're going to do because we're going to skip number 6 until I get back. So if you're looking at number 5, if Cheryl can run 3 miles in 3/4 of an hour, how far can she run in 1 hour? So we could build a rate based off what they've given us. So she can run 3 miles, and she can run 3 miles in 3/4 of an hour. All right, so I've built my complex fraction, and so then they ask how far can she run in 1 hour? So which piece do I not know? Do I know my miles or do I know my amount of hours? Well, I know my amount of hours is we want it to be 1 whole hour, so I'm going to say 1 hour. All right, so now you're probably wondering, how do I get from 3/4 to 1? Okay, because they're not quite as simple as my 1/20th and my 1/8. In order to always get to 1, you might notice from the other two that all you're simply doing is multiplying by the reciprocal. So you might be wondering, well, what's the reciprocal? Remember that the reciprocal is your number flipped, that your numerator and your denominator switch places. So if I were to say 3/4 and I were to multiply it by the reciprocal would be 4/3. So all I do is flip it. Well, what happens when those numbers multiply by one another? 3 times 4 gives you 12, and 4 times 3 gives you 12, and so now I've created a value of 1. So in order to get from 3/4 to 1, you can always just tell yourself to multiply by the reciprocal, okay? So if I multiply by the reciprocal in the denominator by scaling up, then I'm going to have to do the exact same thing to the top. And so I'm going to multiply by the reciprocal up top. And so I'm going to say times 4/3, because since I multiply by 4/3 in the denominator, I've got to do the same up top. So I'm going to go off to the side, actually down to the bottom, and do that process. So coming down here, if I say 3 times 4/3, what's that going to give me? Well, so I'm going to turn the 3 into an improper fraction. I'm going to put it over 1. And then you could go ahead and go straight across, okay, by saying, okay, well, 12 and then 3. Or you could go ahead and look off to your diagonals and see if you can clean up your numbers. Well, 1 and 4 don't have any greatest common factors other than 1. But if you look at your 3's, those do have a greatest common factor other than 1 because both of those can be divided by 3. And if you divide both of those by 3, you're just going to get 1 and 1. And now you're ready to multiply straight across. So 1 times 4 gives you 4, and 1 times 1 gives you 1. And so you've been left with a value of 4. So that means that she could have, if she continued running at that rate, she could have run 4 miles in 1 whole hour if she had run 3 miles in 3/4 of an hour. Okay? All right, so this video has finished. What I'd like for you to do now is make sure that your paper looks exactly the same as mine, with all the same labels, with all of the same arrows, with all of the same, side work. Just make sure that your paper looks exactly like mine. It's a really easy way to make sure that you're understanding as much as you possibly can, okay? Then, after you have made your paper look exactly like mine, if you will then go and watch the second video that goes along with assignment 2. So this was assignment 1 and its video, and now I need you to go and watch assignment 2 video. All right, thanks guys.